We've got our first test this week.
Yeah, it shouldn't be too bad.
No, I don't think so. I've been working on the written part slowly but surely.
Well, did you have any questions on anything?
Not really. Just review stuff for the test, so. I mean, we can do the extension problems, but I feel like most of the extension problems are on the group quiz too, so.
Yeah, we can just do the group quiz. I didn't have any problems with the extension problems.
Yeah. I'm fine with going on to the group quiz. Do you want to submit this one first this week since I did last week?
Yeah, sure. So let me get a pen and paper.
All right, so first we've got the periods of all the 6 functions. So for sine, the period is 0 to 2 pi. It's just the period of like one full thing, right?
Yeah. How would you write that though? Would it just be 0, 2 pi?
Yeah, I believe so. And then cosine should also be 0 to 2 pi, right?
Yeah.
And then tangent. Tangent is, isn't it negative pi halves to pi halves? Might not. I might have to look at that one. Yeah, it's negative pi halves to pi halves. I've got
Secant.
Secant is 1 over cosine, which would make that one negative pi halves to pi halves.
Okay. See, for cosecant, that'd be 2 pi, wouldn't it?
Cosecant, you said 2 pi?
Yeah. I might have that wrong.
This is when I go and look at my notes. I thought it was from 0 to pi.
0 to pi. Actually, I think you're right.
But I might be wrong. Because like when there's asymptotes, is like the up one and the down one included, and that's 1.
Mm.
You know what I'm saying?
Yeah.
Because then, yeah, I think you're right. It's 2 pi because a period is from when it stops. So like one of the peaks of like the bottom ones to the peak of the next bottom one. So that would be 2 pi then. Pretty sure for cosecant and secant that should both be 2 pi.
So for secant, I had negative pi over 2, so it shouldn't be that.
You had negative pi over 2 to pi over 2?
Yeah, for secant.
Yeah, I don't know like how to write the period. I guess it, because like when I'm looking here, it says that the period is just like 2 pi. So that'd be like the length.
So the period is just from the top of the curve to the next top of the curve.
Yeah. So I think like the length of that would technically be 2 pi.
Okay.
So then for like sine and cosine, the length of it from 0 to 2 pi would be 2 pi.
All right. So I understand the length, but how did we get the other number?
The other number like in the pair,
Yeah.
I don't think that we have to have both I don't think we have to have a pair. I think we just have to write like the length.
Just one number.
Yeah,
All right.
for the period.
So Sine would be.
So sine would just be 2 pi. Same with
2 pi.
cosine. And secant and cosecant would also be 2 pi.
And tangent would just be pi, wouldn't it?
Yeah, tangent and cotangent would just be pi.
All right. Looks good.
Sorry, I made that more difficult than it needed to be.
Oh, no, I was lost, so.
Okay, identify which quadrants each of the 6 inverse trigonometric functions are defined. I need to remember the quadrants. Does it go counterclockwise? So the first one is 1, then to the left is 2, then down is 3.
Yeah, the top right one is 1, top left one is 2, and then
Okay.
yeah, that'd be close.
So the quadrants, they should each be in 2 quadrants, right? Or 1, I don't know.
See, like, what does it mean by, like, what quadrant are we looking for? Where the period is in the quadrant, or?
I usually, like, whenever I'm doing a problem with like an inverse function, I usually look at the range of the inverse function, because that helps me know like where it has to be.
Okay.
So like the range of inverse sine becomes, it's usually -1 to 1, but then when you take the inverse sine, it becomes negative pi halves to pi halves. So then that would be like quadrant 1 and 4, but I don't know if that's what they're asking. It seems like what they would be asking. I was looking at our grades for like the group quizzes, and we actually got a B- on that one. That took us like an hour and a half. Yeah, I think the range of the inverse functions determines which quadrant they're going to be in. So like inverse sine, the range is negative pi halves to pi halves, so it would have to be within quadrant 1 and 4.
Okay.
That's how I understand it, at least.
All right. Yeah, I was just looking through the notes, so I think you're right. And then I think inverse cosine would be 1 and 2.
Yeah, because the inverse range becomes 0 to pi.
And inverse, that's just the. Is that just the sign to the -1 sign on the calculator?
Yeah.
All right. I always get that mixed up.
I don't know how to, yeah. I just say like the inverse of sine, so sine -1, or like arc sine, I think is the same thing. So then tangent, the range would go to negative pi halves to pi halves. So that one would also be quadrant 2 and 4.
1 and 4?
Yeah, 1 and 4. I mean.
Then for inverse cotangent, I got 1 and 2.
Yep.
And then for inverse secant, I also got 1 and 2.
Secant, cosecant, I'm not really sure on. Need to graph it. The range gets all funky when you take the inverse
Yeah.
of like secant and cosecant, so I don't know. How'd you get 1 and 2?
See, if I did it right, if I graphed it right, I was just looking at, I just looked at the negative pi halves and then the pi halves, and they were just in the first and second quadrant.
Oh, yeah. Now I see. Even though there's like a break. Okay, that makes sense. Yeah, so 1 to 2 for secant, you said, right?
Yeah. For the inverse secant, and then for the inverse cosecant.
That one would be 1 and 4, right?
Yeah, 1 and 4.
So 3 just like gets forgotten by everybody.
I think so.
Nice. Okay, now we have to graph this with 1 period. Okay. So it's gonna shrink by half.
So the amplitude, 1/2. That's what we have to find. Period would be 4 pi.
Right. When you mess with the X inside the parentheses, what does that do again? Does that stretch or shrink horizontally?
I believe so, because when you graph it, it looks like it's stretched horizontally quite a bit.
Gotcha. And then the one that's like on the outside, that stretches or shrinks vertically.
Yeah, I believe so.
And then it's shifting to the left 3 pi and up 4.
Yes. So for the domain of that, I got just negative infinity to infinity.
Uh-huh.
And for the range, I got 4.5 and 3.5.
Yes.
Which should put that into a fraction to be 9 halves and 7 halves.
Yeah. They probably wanted more in a fraction, I feel like.
Yeah.
I don't know. I don't think it matters because in normal range is 1 to -1, and we're going up 4, and then it's shrinking by half. So you could put 3.5 to 4.5.
I think I'll just put it in fractions just to be safe. That's probably how they
We can
teach
probably
it.
put both. Like
Yeah.
typically when I'm unsure, I'll just put 2 different things that mean the same thing.
Good idea. So is that all for number 3?
Yep. So the last part isn't very difficult. We've got tangent of 7 pi over 6. That'd be -1/2 over -3.
Yeah, I got square root of 3 over 3.
Yep, that is what I got too. It just takes me forever to do the math on freaking dividing fractions.
Yeah.
And then cosecant is 1 divided by sine. So 1 divided by. So 1 over square root of 2 over 2. So for that one, I got square root 2.
Square root of 2?
Yeah, because 1 over square root 2 over 2, and then you just simplify that.
All right.
Sorry, my thing crashed.
No problem.
So we got the inverse sine of negative square root 3 over 2. So that one would be 5 pi over 3.
See, I think I just got pi over 3 for C, right?
Yeah, but aren't we doing isn't it negative for a 3 over 2?
Oh, let me double check. Actually, what's doing the chores? Late back Sunday. Who? It looks like it's kind of scouted over. Keep an eye on it.
Oh yeah, you're right. It's pi over 3. Can I grab the charger? Do you need it? I'm at like 6.
And I got negative pi over 3 again for D.
Yeah, I just checked that. For B or C?
I got both for C and D. Negative pi over 3.
Okay, yeah, that's what I got too.
All right.
I got confused with the inverse sign.
Yeah.
Alrighty, is that it?
I believe so.
Just the participation points. So
yeah, if you just want to send me the link to the video, I'll get everything sent in.
Cool. Sounds good. All right. Well, good luck on the test.
Yeah, you too. Next Thursday, work again?
Yeah.
All right. Well, thank you very much.
All right. Sounds good. We'll see you next week.
See ya.
Bye.